And so we should, the other obstacle is that our auto router Cadence, and it's the same auto router that, the same tools that I am using Cadence, hit already 20 and it doesn't fit on 20. So at that point, thanks to this organization, and then I went down to the design of the assignment of the pin and grouping the traces in a certain way, it fit in 8 layers of signal and 6 layers of power and ground. So this means that this is the advantage of technology. So the design, simulation of the entire system, prototype on a breadboard, and we will see also that, and then final board that is the board that should be used in production. Second statement, providing, always from the press release or slide 64, providing the capability to exchange information received from neighboring detector element. And this is what is giving us the possibility to make the 3x3 proving, but eliminating the scatter, so improving the sensitivity, eliminating false positive, and also the spatial resolution. So this is the concept. It means that I have this structure, this design, this concept within the chip, and then within the board, and then we see within the chassis, and within the board, well, are traces organized in a certain way. Within the chassis and between chassis is this flexible printed circuit. This is carrying LVDS, low voltage differential signal, serial, and it's a good way to keep the integrity of the signal on a flexible printed circuit with a control impedance 100 ohm. So this will go on in between the boards, and also longer one between the chassis. Next sentence, and to execute complex algorithm that can measure more accurately the total energy and the spatial resolution of the incident photon. So here is the sum of 9 elements. It provides better resolution than the sum of 4. The spatial resolution calculated on the sum of 3 to the left minus the sum of 3 to the right, it gives a better spatial resolution than 2 and 2. Again, design, simulation, and implementation, everything is on this machine. As well as eliminate the parallax error of the oblique photons. So because of this possibility to execute entirely the real-time algorithm, then I can execute any calculation that will correct, measure and correct the parallax error. So I can get oblique photons, and all this is implemented in this board. The way the signal from the detector are connected to the set of DSP at each electronic channel. So instead of using multiplexer in a parallel system where you get one point to many points, and you get the problem of fan out, the problem of current, the problem of capacitance, and so on, I have everything point to point, same distance, that goes from the detector, well, from the detector to the electronic is not same distance, but equal distance among them. Okay, so this is an important aspect of the innovation. And finally, the very last one that is matching this innovation in the electronics is the construction of the detector that is completely different, does not have this slit, and will require a different electronics. And then the very last is when the actual length of the detector is doubled, the number of photon capture is increased by a factor of 4. This is the transparency that we have seen before, the concept, and this is the implementation that we will see later on, the hardware. Goal of this review. History shows that innovation that makes a breakthrough most of the time were delayed because of skepticism toward the revolutionary approach. With your help in this review, the review panel and the people in the internet, so please ask questions, would it be possible to convince the skeptics, determine if my innovation provides 100 or 1,000 or, as I said, over 4, I choose a way in between, over 400, as I claim, times efficiency improvement in the PET technology. And if it opens a whole new field of application not envisioned before, that I would like to have your contribution on that. In the past, I have written a book, and you have a copy about this innovation, presented at a conference, described the concept, done simulation, built, as you will see, new components of this project. Now funds are required to replicate this. And what I've done in order to get the full 3D CBS. With your help, can we shorten the time from the innovation to realizing the benefit to the public? Or, if you don't believe that this is possible, please spell out scientific argument that invalidate my claims, and we will discuss about that. I thank you. Let me see. I thank you, all of you, and also I thank these companies who say Terra. Oh, by the way, we have Jones Days here, represented Steve Flugiger. LVC Technology for a lot of instrumentation and components, and our device, they provided components. I would like to thank the Dallas Foundation for a grant, Photonis for providing for the test 16 photomultiplier, and Kind for providing for a test high voltage power supply, and Saint-Gobain for providing the crystal for testing. Thank you.
Thanks, Dario. That was a lot of information in a short period of time here for everyone to assimilate. And we're running rather late, but do we have any questions over what's been presented so far? And we also would like to have any internet questions that come in from people participating on the net.
Are there any questions from the net?
I'm waiting on the modem.
Okay.
I'll tell you in a minute.
You'll have a chance to ask specific questions on particular details of all of these components of the 3D CBS system. As we go through the, maybe we could go on to a little presentation, Dario Crosetto, the equipments and tools that you've developed for this project.
Well, that will be after I think that is the next session, and we will move to the room where these are developed, and in particular what we will see all the software and how we can simulate everything, and then how I stage this with a prototype board on an FPGA field programmable gate array, and then from the FPGA to IBM PC board. The reason why I choose IBM PC board, I had the choice of IBM and VME. VME I know that is more reliable and typical for industrial application. We were using also VME at CERN in Geneva.